Okay, good morning. My name's David Lyth. I'm a principal, no, not a principal, I got that wrong. A Premier Field Engineer with Microsoft. So primary capability is SQL Server. So I get to tour around talking to people like you, talking about what you're doing with SQL, how to make it better. And with me, because you guys thought you were only getting one speaker, but we have.
Pat Martin, also SQL Premier Engineer. I work in Auckland and David works in Wellington.
Thank you, Pat. So we've got three distinct topics that we're talking under the general umbrella of Elastic. So we'll cover those all. For questions, if we can do questions at the end of each segment, and that way you guys will not forget the questions by the time we roll through the other two topics. So first off, just positioning what these three things are and what their full names are, so when you're doing searches you can actually find them. So first off, we've got SQL Server Stretch Database. So this is an offering that's primarily targeting your local boxed version of SQL Server. It does use Azure, but it's really targeting your problems that you have down in your local data. The other two is your SQL Database Elastic Database Pool, which we'll just call Pool because it's shorter, is a SQL DB in Azure feature. Also, Azure SQL Database Elastic Scale, which we'll just call Shard because it's much shorter, is also a function of Azure SQL DB. So these last two are really PaaS offerings. The Stretch is for your local problems. So we'll talk about Stretch first. So Stretch, I have been thinking about buying a mountain bike to go with my road bike. So the problem, apart from getting permission to spend the money on a bike, is that this is where we store the bikes at home. So it is full up of the kids' bikes and my other bike. Now if I want to expand that, there's a bank on one side. There's also a garden that I'm supposed to plant flowers in quite soon. So it's really difficult to expand. So that means that my plans to buy a bike are really pretty much on hold. So when we go into work, we get the same sort of thing when we're looking at our database environments. You've got the business who have got the cold data. So cold data being your transactions that you're finished with. They're more than 3 months old. People very rarely look at them, but the business still want to be able to hang on to those, and they want them online. They don't want to have you restore a tape and come back next week to tell you what the data on the tape actually was. And they want to be able to get to query that data from the same application. They don't want to go and have some weird archive store that they've got to fire up and remember how to use. So big demands from the business to do that sort of thing. So from your administrator's point of view, what we're seeing, uncontrollable growth. So you're looking at your stats and going, my table just auto-grown again. How do I work around that? When you're doing operations on these databases that are growing, things like your index rebuilds, your backups are just growing and growing over time. And if you've got a fixed window to get those done in, you've suddenly got a real pain point. You're forever trying to get more disk to put these tables onto and going through all the pain of your change controls, trying to get permission to increase the storage, which can be a real pain. And the constant pain point of you trying to go to the business and say, can we delete this? And you get, I don't know, we're not really sure is the answer. And with a lot of your legacy systems, the original owner has been long forgotten. And so you haven't really got a clear business owner to give you a definitive yes, delete that terabyte of data, we don't need it. So what Stretch is doing is the idea that you've got a set of hot data, which is your current in-use data. Keep that locally in your on-premises SQL Server instance, and then take that long tail of cold data. So if you've got 7 years that you have to keep for tax reasons, let's take that up into Azure and put it up there. And do it transparently so that no one knows that it's actually gone there. So really, cloud on your terms. You can stretch just what you want out of your database. You don't have to jump off the cliff and commit to everything being up there. And you've got the right stuff in the right place, so you can still keep your local performance for your hot data and then better price points for your cold data. And the DBAs get a much nicer time of it. So it's sitting there, we've got trickle data movement going on to take care of getting the data in the right place, and the query processing just happens. You just issue a select statement. So yeah, your business applications keep going, because as far as the application knows, everything's still in the same table. Your DBAs are happy because everything still keeps going, and your developers don't know any different. So what do we actually do for Stretch to work? We've got our beautiful on-premises SQL instance, and we've got a couple of tables here. We've got two scenarios going on. One is we've got order detail, and that's we've got some hot data in a table, and then really common today, people have an archive table, and you have a weekly job that moves your cold data off into an archive table. The other one is the transaction detail table, and that's just one big table, and it's got stuff from the dawn of time in it, and your hot data in there as well. So what we do, we've got up in Azure a SQL DB environment. So you've got storage and compute up there in Azure. You then grab that old archive table, trickle move it across, and store it in that Azure database. The other scenario where we've got some cold data in a table, move that across and just the cold rows. So moving the entire table is in the current CTP release of 16, so that's 2.3, which got released yesterday or the day before, depending on your time zone. The ability to work on a predicate and just have some of your table moved is coming, but there's no announced release target for that yet. So, but that's the intention for you to be able to do both of those scenarios. So transparent access, so your queries are just querying the table in your local database, just the way you would before you implemented this. So you put your query in, comes down. If it's only needs data that's on your local instance, it'll only go there and pops the result set back. If you've got something where your data is remote as well as local, then the query plan knows about that, splits it up, goes to both locations, grabs the result sets, and then puts them together and sends them back to you. So completely transparent to your queries. So the other great thing about this one is backup and restore. So if your database is growing and growing, your backup size and the time it takes to get that backup finished take longer and longer. So that's your regular backup. What happens in this case, the backup is only backing up the tables that you've got in local storage. The ones that are there in your Azure database are not included in your full backup. It is a SQL DB in Azure, so you've got all the usual mechanisms to protect your data up there. So there's 3 replicas minimum. There's backups being taken of those that are being done just part of the SQL DB service. So you've got all that there. But it means that your local backup can be a lot faster. And if you've got, when they release it, predicate-based stretching, you've only got the hot data in your local table to re-index. So if you do a full re-index of your table, it's only re-indexing the bit that's in your local storage. So that can really help with re-indexing.
So David, you mentioned predicate-based stretching. Do you
Yep.
want to talk a bit more about this later? Or?
So predicate-based stretching, what I mean by that is just the idea of being able to have this transaction detail table to be able to say, I want the last month's rows to be held in my local database and the older ones, stretch them out into Azure. So as I said, that's not there in the... You're being waved at, Pat. We're okay for now anyway. So yeah, that's what I mean by predicate-based stretching. So just the idea to split up a single table. But that's not there in CTP 2.3, but it's coming. So just having a look in stretch in action, which because we're all techies and we like to see things actually happening. And I'll put my glasses on so I can actually see the screen. So the first thing that we need to do, so this is just a SQL 16 database sitting on my local laptop. The first thing that we actually need to do, and I've done some of these things beforehand, is run spconfigure and tell the instance to turn on the capability to have stretch. So just a simple spconfigure flag, nothing exciting about that. Now I do need to have a SQL database server hooked up in Azure. And so there's 3 different ways of doing that. Ooh. On here there is a task wizard that you can go through and enable stretch on a database. And if I actually go to one where it's not actually enabled, like my slim one, we should be able to pop up the enable dialog. So it goes through and it will step you through all the tasks that it needs to do, which includes things like creating the Azure SQL database server. And just to be clear, that a SQL Azure database server is not an instance, it's a logical construct that you just hold SQL databases in. So it's a slightly different concept, but it is there really just as a place for your databases to live within. So you've got to have one, so you can do it either through that task, through the wizard. You can do it through PowerShell, of course, because we can do everything through PowerShell. New Azure SQL database server with some parameters. Or we can go through to the portal. And today, the only one that lets you name the server is going through the portal and doing it interactively. So I used that because I wanted to have a cute name for this. So I created Stretchy1 as one of my database servers in Azure. You then create a credential. So that's saying for this database server, I'm giving it the admin username and password. And obviously, XXX is the password that you get out of Azure portal for this database server. In the documentation, it says sysadmin, but it's really the database server's password, which is a slightly different thing. So that's stored securely inside your local server. You need to go into Azure and actually set up the firewall settings on your database server as well, because by default, all of those things are blocked in the firewall that's in front of your SQL database server. So it's not just open to the world. And then this bit here is actually saying we would like this AdventureWorks database to be able to use stretch, and its partner in Azure is the server Stretchy1. And this takes about a minute to run, and it actually creates a new database on that database server and gives it a name with a big long string on the end of it. So it becomes the partner for this far end. And then finally, whoa, grimness. The first piece of code and it goes bleh. Nah, grim. Fortunately, I've got one that I prepared earlier.
That's good.
Yes. So I have done the far, far away table. So this does highlight that there are a number of constraints and blockers at the moment for the stretch feature, and one of them is check constraints. So the SQL Upgrade Advisor does have a feature advisor on it for StretchDB, and it will go through and check these blockers for you. So yeah, check And you can't do some of the large data types. XML is one of the ones that breaks as well. So that will actually start the migration of your data from that table through to the equivalent table in your SQL database in the Azure. And then we've got a DMV that will tell us what's going on. So this is just a slice of letting us know what the background task has been doing. So this is running every 20 seconds, and it's looking, is there any new data in the table that I need to migrate up? And it's doing it in batches of about 5,000 records. So it's there intended to be a low impact background task that will move stuff through for you.
So David, moving this doesn't impact the server throughput?
Everything impacts server throughput, but it's intended to have minimal impact.
Right.
So that's setting up Stretch. So once we've done that, I will go back to my far away table, because that's the one that I've stretched. And I can't remember if I used an underscore. Yay! I did use an underscore. So this has been quite happily just stretched up to the cloud. So all of the data for this table is sitting in an Azure database. And it's just popped through. And you can see here, it's just using a remote query. And if you look very carefully, you can see that the remote query is referencing a RDA AdventureWorks database with a big long thing on the end of it. So that's the guts underneath. It's just doing remote query. It's also doing a query of the local table because it doesn't know whether all the data's been trickle migrated or not, and then joining them together. And again, the intention for the predicate-based stretch will be that you may still have some data in your local table, and it will quite happily join that for you. Come on. Let us just scroll down. Come on. Pat, what is the thing? Hey, come on. Yay! And this is really just doing the same thing, but just saying you can quite happily do. Oh. Grim. We got 1 out of 2 queries running. One more time for luck. Yay. So yes, you do want to check out that your network is actually reliable before you start doing this sort of stuff, which is the same for any sort of cloud infrastructure. And I'm sure there's many people who can talk to you about ExpressRoute and all those wondrous things. So this is just showing that you can quite happily still do things like joining back to your local tables, and it all just works. Again, if we look at the execution plan and drill down to there, you'll just see that there's some remote queries which are doing the go and grab the archived data that's been stretched up to the cloud. Now, this is just saying that you can quite happily still do an insert into your archived stretched table, but you're not allowed to do any updating of that table. So the idea is this is cold data, you've finished all your modifications to it. The only thing that you're doing is migrating new data that's now cold and dumping it into this table. So no updates. If you want to do deletes, there's some documentation up in books online for this about using partitions and swapping partitions out. Or you also have the option to stop the stretch process, clean up the data, and then turn it back on again. So there's a couple of ways. This is all CTP, so they're quite happy to take feedback from you guys if you don't like some of those things or you think that it should be improved or added to, and they will take that on board and see what they can do about that sort of thing. So that is stretch, and we will pop back to there. So Questions about stretch? Yeah, lots.
Is there any other option to trickle up, like, we've got huge databases of 80 million rows?
You want to do a bulk export and dump them in? Not at the moment, no. So it's designed to be just there as a trickle, and they've said that they're blocking deliberately any sort of direct access into that stretched database to avoid people going in, mangling things. And yeah, so just to keep it as a under the covers type of database. I mean, if you go into the Azure portal, you can see it. But again, if you think that that's a good thing to have, send feedback through CTP. Yep.
So when you are moving record from local to remote,
Yep.
what's happening with the transaction log in the local system?
So it is still a transaction. I haven't looked under the covers. Don't have access to that source code. But they do say that that is fulfills ACID, so they are still rolling back if the whole thing fails, and so you've still got the record there. So it'll still be logging transactions, yeah. So again, if you've got a big volume of data, you'll start seeing your transaction log with stuff. But it is throttling it, so it's only 5,000 records every 20 seconds, so you're not going to flood the thing. Yep.
Are the indexes also copied up? So that obviously when you do a remote query, if you drop the data in Azure DB,
Yep.
the indexes that you would have had.
I haven't played with that. I'm guessing that because when you do the enable for stretch, which is, where are we? So you alter the table, that actually builds the table on the Azure DB. So I haven't actually checked to see whether it builds all of the indexes, but there is some stuff in the documentation. Yep.
Is there a keyword to say just local store and not go cloud? If you want to make sure you're dealing with fresh transactions only and not have that as an Azure search.
You mean you want to say, I never want to go to the stretched portion?
Query. Show this month's sales. I don't care about history. I only want this month's sales, so I know to not go there.
So what David mentioned before is that the predicate-based trickle feed is not in the current CTP. So predicate-based, just for your understanding, is simply a where clause that determines which data is migrating. So you'd have to manage that in terms of your predicate.
Hmm.
Okay, so if my query was where month equals current month, the compiler would know not to go off in Azure. Okay.
Well, we would hope it will, because at the moment, all that's released at the moment is my whole table is up in the stretched database.
So David, I think we'll crack on now.
Yeah, there's one guy with his hand right up at the back, so
Pretty much cloud is the only destination for stretch. Can you stretch only to Azure or
correct.
can stretch SQL Server?
You can't, yeah, so Azure SQL DB is the only current target available for stretch DB, yes.
What did you have in mind? I'm curious. We'll talk later.
Yeah,
Another box running slow disk.
Right. Yeah, thanks, Dave.
yeah, no, they've explicitly said in the FAQ, no, we're not targeting local. So you could say it's possibly a little bit of a sales pitch for Azure DB.
AWS?
Shh.
That's what I was wondering, was kind of back of my...
But no.
All right, let's move on.
Okay, so that's stretch. So our next topic is pool. So just back to basics. So Azure SQL DB, we create a database, and part of creating the database is saying how big should it be. And we've got DTUs. So how many people are familiar with the DTU term? Reasonable number. So database throughput unit, and it's a completely artificial metric which does relate sort of to the underlying compute power underneath there, but it's really just a comparison unit that something with 200 should give you more throughput than something with 100. That's all it means. So you go and you create your database, say how big do I want it to be, and you get some advice from the portal that goes back and does analysis for you, and will do some suggestions on maybe you should make it a bit bigger, maybe it's too big and you're wasting capacity. But at a database by database level, it really is a manual sizing exercise to figure this out. So that's fine when you've got one or two. When you start growing up, then it starts to get more of a challenge and you've got more legwork involved. And especially when we go to the scenario on the right-hand side, where we've got multiple databases and we haven't got predictable demand in there. So some of the examples that we use for this, you've got a ticketing site where you've got a database for each city, and the wiggles move down the country and each database gets hit as they go to release tickets for each site. Or you're doing SaaS as a service for payroll, and the companies that are using this have their payroll cycles on different days. So they spike up their demand, then go quiet for a fortnight, and then spike up again. So trying to size up your individual databases can get a bit tricky. So this is just an example of what happens. So you do your best effort sizing. They're sort of pottering away with demand, and we've actually misjudged the one on the left-hand side, which suddenly gets huge burst of activity, goes very, very horrible, and then completely breaks. So obviously that's a bad thing from a service point of view for your customers. So what we can do with Elastic Pool is actually put all of these into a DTU pool so they can all actually take that capacity from the overall pool and then size themselves up, and each of them as they're going through can actually use those DTUs, grow to a larger consumption, and then drop back down. And as long as your aggregate usage is still below your total pool size, then everyone's happy. And obviously, the more databases you get, the more elastic each individual database can then be. If you've got, in this case, probably about a dozen databases, they can then each individually grab from that pool. So they were very beautiful accordions. I thought whoever did that had far more time on their hands than they needed. Because I didn't.
Needed audio.
Yes, need an audio of piano accordions. Anyway, concepts. So all that we've got really is we've got a bunch of databases, we put them in a pool. There's a term that they use for eDTUs, which is just DTUs that you've put into the pool for anyone to use. And just a note that your gigabytes of storage are also tied into this bundle as well. So if you've got a database that's got lots and lots of storage requirement, it's not going to be a good fit for this one. There are some tools. We're not going to talk about those in detail today because this is just a quick fly through. And whenever you get a pool that's available for everyone to use, you get the classic noisy neighbor syndrome. So one of your databases could, if it's unrestrained, take all of the DTUs and leave none for anyone else. And then you're really in pain because the applications that are using those other databases will start to break horribly. So there are some settings that you can use to help work your way around this. So obviously we can control the total number of DTUs that are available to the pool. You pay more, you get more. Simple setting. We can also set a maximum per database. So if you've got 200 DTUs in your pool, you can say, I want any one database only to be able to consume 100. So it can take 50% of the pool and leave the other half for everyone else. You can also do it the other way around and have a guaranteed minimum per database. So you could set, in this case, 10 DTU as a minimum. So that says every database always has 10 available. Obviously that will constrain the number of databases that you can put inside the pool, because 10 times 20 is 200, and that's your total DTU. And you're also, if you're doing that, losing some of the elastic capability because they've all got 10, that's it. No scaling up, no scaling down. So you need to think about those numbers a wee bit. And so I just wanted to step through how you actually configure a pool, and we will punch the magic button. Where did I put those? Whee. So hopefully it hasn't timed out on me. So the first step that you do is you've already got a database server. So in this case, one with a horrible name, which I'm not going to even try and say, because it came out of the where's my maximize gone? Sorry guys, that seems to have done a wee timeout on me. So we've got a database server. So this is an Azure's database server, and we've created a bunch of databases. So if we want to set up an elastic pool, this is a function of this database server. We just go in and create a pool. Yeah, loading, thank you. This is a preview feature as well, so things may change before GA. We give it a name. We pick a pricing pool to take it out of. Come on. And then we add some databases into this pool. So here we're just taking databases that we've already configured. So we've gone through the standard created SQL DB, and we put them into the pool. And we can configure performance. So this is where you can pick, yeah, I'd like 1,000 eDTUs, please. And you can set these min and max figures as well. So we'll just go with the defaults for that. And again, the pricing changes from preview to GA, so you should take the pricing with a sort of a little bit of dose of salt. So that is going away, and it's busily creating that pool for me. Now I do have one. Oh, here we go. One that I created earlier. So yes, thank you, at least one person got it. So this is just saying that we've got the pool, and you can go in. It says 3 databases. So here you can go in, and if we don't really like yet another database being in there, we can actually remove that database from the pool. So that then goes back to being a singleton with its own contained set of DTU that it's drawing from. So no longer is it in the pool. So you can do that, and you can go back in and add new databases through that. So quite configurable. Come on. Yeah, whatever. It didn't like me. Yeah. And again, if you need to, you can come back through here and actually change the various total size of your DTUs and those min and max settings based on if you know from running the thing that those aren't right. So quite configurable. So that's the basics of configuring a pool. Obviously, you then go in and look at how your applications are working, but you're still using them just as individual databases from the application point of view. So this is all about just being able to give each database some more capacity to deal with spikes in demand from your applications. And so that's pool. And so now we will punch back to the Magic 5. And I'll hand over to Pat to talk about
All right.
shards.
Thank you. So, present time. Quick question for those that were paying attention. What is a predicate-based trickle feed?
Predicate is we can't have the data based horizontally based on
That's true, but what's the predicate aspect of it? Sorry? Hands up. You. Where clause? Go. All right, very good. All right, so let's move on and talk about elastic scale just in the interests of time. So my name's Pat Martin, also a SQL engineer with Microsoft since 2002. So just talking a little bit about elastic scale, and we're moving on now and talking about sharding. So this is a term or a concept that you've probably come across a number of times, the concept of a shard. A shard is a splinter, piece of glass. It's a piece that's separated off from the main stream, and it kind of lives by itself. And there's no difference here. This is the same in terms of a shard. So think of it as scaling out rather than scaling up. So David talked about, automatically getting more DTUs in the pool, automatically growing a database in terms of its capability. So here we're scaling out. We're saying that our application workload doesn't quite fit in the unit of scale that we've got, but it might make sense functionally from a business perspective to scale sideways. Maybe we have a shard per customer or per tenant. So this is really the concept of sharding. It's useful in different scenarios. There are different kind of business points where this might be valuable. An example here, sensor or telemetry processing, real-time processing. I'm ingesting a lot of data at high speed. I don't necessarily want to run analysis queries across all of that in a short time frame, but I might want to query that data based on some kind of temporal aspect like a month or a week or a year. So I'm collecting it at high speed, a lot of data, high volume, but I want to query it in pieces. So this is this idea of this fan out by month. We could also fan out here. You see this hash1 and hash2, another way of doing this. So instead of shards that are split up over time, maybe we've got shards that are split up over customers. So we actually have a customer in New Zealand, in Wellington, that's been doing this for a long time, very successful company. I won't call them out in case I mention them in a way that they don't like, but they're pretty high on the stock exchange in New Zealand, and they've been doing sharding with databases for a long time. And they're using SQL Server and always-on technology. So it's not new, but some of the support that we've got for it, particularly in Azure, is quite new in SQL Server 16. So high-scale OLTP, this is another reason why you might use sharding. You're just dealing with a lot of data, and you want to distribute that out sideways. You can kind of think of it as partitioning, but on the database level in Azure. That's kind of a way to think about this if you need to conceptualize what's going on. And you might have different types of clients or different types of customers. Some of your individual customers might be very, very busy, so you want to give them their own shard. Some might be shared. You might have a lot of customers, but you'll put them together for price and management optimization. So you can do that. You can move users between shards, and I'll talk a little bit about that. That's problematic. You've got to take into account that if you're doing that, and you will need to do it because you're going to rebalance your workloads, data will be moving while you're querying it, while you're running transactions. That's taken care of in the interface, but you need to think about that if you're moving data. That's called split merge. Lastly, this data-dependent routing. This is really why you do this. I've got this customer in this shard and this customer in this other shard. They're somewhere in the cloud. You don't know or really care where they are because you're not looking after them. But when a query comes in for customer N, it needs to go to the right place. So there's an abstraction, there's a middle tier that kind of sits in the way, which is called a shard map manager, and it's mapping your key to the shard location because it needs to know where to go. So it's a fairly straightforward concept, right? This is this concept of shard management, and this is called data-dependent routing. It's based on a key. You need to know the relationship between your shard and your key. So, what types of tenancy and types of shards might we consider? So, single tenant per database. Each tenant you manage in Azure is stored separately in a different database. It's completely isolated. It's in a different shard, it's in a different place. Or multiple tenants per database. It says here less isolation. That's fairly self-evident from the fact that you've got multiple of them in the same shard. And you may have different security considerations depending on whether you're single or multi-tenant, or some mixture, some hybrid model of that. So this is a function of your application design. You decide how this sharding is going to work, who lives in which shard, and whether that's a shared resource or not. It's kind of an application decision to do that. And then the last point here, temporal model, sharding based on the date time. The most recent one's constantly sharded with newly arriving data. So this is my hotspot. This is my currently running data. And then as you near capacity, you automatically add a new shard. I say automatically. There's something called Azure Automation, which allow you to do PowerShell runbooks to automate this kind of work. Because you're not always going to be there manually adding these shards. It's going to be a function of the workloads that you're running. So it needs to kind of happen under the hood. So there is a database client library. I'm going to show it to you. A little bit nervously because I'm a database guy and I'll have to use Visual Studio. So I always kind of feel I need a bit of a shower after I've done that. But hopefully you'll kind of bear with me. So there's a client library. You install it as a NuGet package. You build it. There's a reference to it created in Visual Studio. And it gives you the interfaces and the support in the language of your choice. And there are also PowerShell interfaces also to this client library. So you get to choose how you're going to manage this. PowerShell is a wrapper. It uses a module. There's a manifest file that loads the DLLs. So it's pretty straightforward. It's not overly complex. And the library provides all of these capabilities. So the main ones you need are who goes where. So how do I get this particular customer into this shard? And once you've split them up, from a management perspective, you need a way to put them back together again. Because you might run a query across the shards, or a DBA is going to manage from kind of a holistic perspective. So this is this capability that's provided by the client library. Okay, so you can do it statically, or you can do it auto-magically using Azure Automation. So this is a little bit of a drill down into this client library. There's a shard map manager that takes care of what shards I've got and how individual shards are mapped to the keys themselves that you manage. And that's a database that's going to live in Azure. Data-dependent routing, I'll show it to you. I'll quickly jump into Visual Studio. This is a way that instead of just using ADO.NET and getting a connection object, there's a factory interface that sits in front. You get a different type of object that goes out from the shard map manager and says, where is this shard located? And what you get back is a connection. So it looks like a normal ADO.NET connection call, but actually what you've achieved is data independent location to the target database. So it's pretty smart. Multi-shard query to run a query across all of these shards. This is quite challenging, I think, from a technical and performance perspective, because you might have many shards. You might have hundreds of shards. And you might want to run queries that bring all of that data together. There's going to be a few challenges around doing that and interesting times in getting it, but it's certainly fully supported. The concept as well, I talked about splitting and merging these shards. So one customer gets very, very busy, or one customer actually isn't doing much. You want to move them for cost reasons or bring them together. So this is a real-time shard migration that's going on. So really this is the way that it's working. This is this client library. There are two ways in which you can create these shard maps. You've got here a range or a list. So what we're seeing is a range at the bottom here. Customers between 0 to 100 are going into the shard on the bottom left, and then 100 to 200 and so on. Some of the folks I've worked with, they actually do it in a much more discrete way, and they've got specific customer IDs that they allocate. As a new customer comes on board for their business, they're allocated a unique ID, and that ID is used to determine the shard that they go to. So sometimes this technology fits very easily into the way that you manage your business. Yeah. So that's what's happening. Then you have the databases here that map the shard map manager. It has a map. The map knows what shards you have. It knows what server they live on, and it knows which individual shard is managing which keys, which is pretty much all you need. It's a lookup table essentially that you're managing. Moving right along, we've talked a little bit already. So here's an example of that. The developer writes select star. Well, hopefully they wouldn't write that, but something similar. Go and get some rows from the customer where the customer ID is 104. So it goes off to the shard map manager to get a connection, because the connection has to take this client to the right shard where customer 104 is located. And that's what the shard map manager is doing. And from a programmatic perspective, it's not terribly onerous. It does look like you're just getting an ADO.NET connection. And then you'll be rerouted and go and run your queries or your updates. Split merge, that's a separate set of capabilities. There's a separate NuGet package and install to manage that. It can get a little bit tricky. As I say, there are flags and parameters in the interface to manage split merge, and when you're doing multi-shard queries, there are flags as the developer that you need to take care of. Because if data is moving in real time, this is something that you need to consider in your application, particularly if you're doing some transaction management and stuff's moving underneath you. So automation, I mentioned it briefly. Azure automation, this is a PowerShell provided technology in Azure. You've got Azure automation. It uses a set of runbooks, PowerShell workflows. We run PowerShell classes if anybody needs to know any more about that kind of stuff. But this is essentially your SQL agent in the cloud. So you configure jobs to run against these shards. Or you can configure automatic changes to the size or the width of the shards based on decisions that you make when you create the batch files. So this is your way to automate the shard management based on your business. Yeah. Okay, so that's pretty much it. That was short and sweet as far as the slides go. I'm going to try and switch over to here. I'm tied to my phone, probably about the best internet I can find. So we'll see how this goes just quickly. So what I've got here is my Azure subscription. I've got some databases installed. I've got Management Studio. So Management Studio is connected. I've connected Management Studio to my Azure server. So here's my Azure databases. I'm just managing them directly from Management Studio, providing I can connect. That's wonderful. It's great to be able to do that. And then in Visual Studio, what we've got here is this elastic scale starter kit. So if you want to go out and have a little bit of a play with this, find out how it works, you go into Visual Studio 15, you get the online samples and you do a search for the elastic scale starter kit. It's a NuGet package. You come down and compile it and install it and build a set of DLLs. And then when you run it, what it's going to do for you is it's going to fire up this interface here, create shard map manager and add a couple of shards. So we'll do that and see what happens. This is going to be very much based on their connectivity. So there we go. So I've put a breakpoint here. Let's put this diagnostic stuff out of the way. So here's my breakpoint. And it's just a shard map manager factory. So I'm getting one of these shard map managers. That's what it's going to do. And it's going to go off and it's going to run that and give me back this manager that's going to allocate all of these shards for me and keep track of this relationship between which customers are actually living in which shards. So here we go. It's getting a shard range map. Let's move on pretty quickly here. And now it creates a shard map. The shard map is where everything's kept. And it's just a table. Right? So it's going through, it's creating the shards, and it's creating the shard manager database, which is holding all the metadata that holds these things together, and it's creating the shards. All right, so if I let that just go on a little bit, and then what we should see, once it's come back to me, we'll actually see, this just depends how lucky we get here. Let's go over to Management Studio and see if we got some more databases turn up on our database server. If we've got connectivity. We do. It's a miracle. So here's our shard map manager. We didn't have that before, so that just got created. When I said create a shard map manager, we didn't have any shards, but now I do. So that just got created by that same DLL. So these databases are holding tables. They're holding metadata, but they're also holding real data. Because that Elastic Starter Kit, it also ran a SQL script once the shards were created to create some customer tables. That's why you're seeing things like customers and orders here, because this is the logical part of this application. All right, so just in the interest of time, I know David's going to start getting grumpy with me. He does that a lot. I think it's something to do with folks from Wellington getting grumpy with folks from Auckland, but that's all right. So then what we see then, if we come back, and what we'll do now, we've added the shards, we've got our shard map. I'm going to insert sample rows using data-dependent routing, which is the penultimate one we'll do here. So then what we see is we're going to add a customer to the shard map. Right, so this is actually, it's on a breakpoint, it stopped at this location in the code. So it already got a connection by connecting to this shard connection map manager, which kind of gave me this virtual connection back. And then based on who the customer ID is, I'm looking at customer ID 129 in the debugger here. The shard map manager is going to say, oh, okay, customer 129 is in shard 0 or shard 1 or wherever that shard happens to be. So magically that data would turn up in the right place. So if we go back to our customers, depending on which ones they actually look at, here's shard 1, and it depends, there's our customer 129 that I just showed you in the debugger. So that's nice, it just created that row. And had it been a different customer ID below 100, it would have gone to shard 0, right? So it's all provided by this library, and it's really not overly complex. And then the last thing here, just quickly, is a multi-shard query. This is a query that's going across all of the shards because it has to bring this data back together to give it back to the client. So what that does is it goes to the shard map. So apologies, DBAs, that really don't have a clue what you're looking at here, but it goes to the shard map factory class. It's an object in .NET, and it gets all of the shards. And it goes through each shards and then creates this connection, which is a multi-shard connection. So by the time you get your connection back, that connection is actually going to get run against all the shards that came back from that shard map. So my query is now running against all of those databases. This is the implementation here. So this is what's happening. All right, that's probably enough about that. But you get the idea. There's a library that supports the sharding. You do need to know from a functional perspective how you want to shard things. You know, how are you going to charge people for your business? How does it make sense to split these shards and split the data across these databases? So that's really it. I don't know if David, if you want to just wrap up.
So just briefly, any quick questions for sharding for Pat?
So I haven't seen any of that in the libraries. To be honest, I haven't fully explored that. But I haven't seen any specific authentication or authorization related functions to support sharding at this point. So there's two. The question is, how do I allow for manual movement of data between shards? So the first part of your question, data going to a new shard, this is something you'd have to take care of using a combination of the client-side libraries and the Azure automation in PowerShell. So I mean, you've got full control over when new shards get created and how data gets moved from one to the other. But to move data from a previous shard to this new shard that you've created, you'd have to use the split merge capability that I mentioned briefly, which is another set of libraries, and then you'd have to be aware in your application about the fact that this data is moving. You basically have to go into a quiescent state from an application perspective while the data is moving to the new shard. No, it's internal to the API. You kind of do it by setting the right parameters when you make the call. That's kind of exactly what you're doing. But it's not explicit, it's just part of the interface.
Okay, Pat, I think that we need to just tidy up because we're keeping people from their lunch. This is starting to drift away. So, just our compulsory slides. Most of these are things that have already happened. We are down in the ballroom over the road after lunch talking about mission critical. So we're going straight over there. Find us later, but all this stuff is published up on Channel 9. This is our ad slide. So if you want to get in contact with someone from services to talk about some more, there's a email alias and various resources, including Channel 9. So, and completing session evaluation. So we do have a couple of giveaways.
Just before we disappear, I've got two giveaways left. I do want to give them out, so don't run out the door.